don't have red.
You don't have red. You don't have red?
No.
Anyone else the same color?
Green or green and red?
Oh, the green one. What fun. Oh, green or green and red over there? So you're going to do red, green, blue. Anyone else need the tape?
Yeah.
And I'm watching my time here, and I'm going to treat this course like a high school class as well, and split it into segments of 15, 15, 15, but now there are 10, 10, 10, because that's your attention span. I always start out with the eyeball with the kids, and I'm going to with you, but I'm not going to go into as much detail, because the kids don't all know how an eyeball works, and I talk about the parts of the eyeball, but really what we want to concentrate on is the retina, and what's back in the retina there are rods and cones. And what color cones do we have?
Red.
Red. Kevin only has red. Red, green, and blue, that's all we have in the back of our eye. And that's a huge thing for the students to think about because they think of, what we see is what there is. And when we're trying to teach the electromagnetic spectrum, it's like, no. The stuff we see is red, green, and blue. That's all we see. There's lots of other stuff that we can't see, the infrared, the ultraviolet, all the way up to the end of the spectrum. So I spent a lot of time on the eye, passed it around. Anyone want to see the eyeball? Giant eyeball? Anyone? Pass it around. It falls apart, so if it falls apart, just put it back together. Kids now don't get that back in grade school like we did. We had a giant eyeball in my classroom, I swear, when I was in 3rd grade. And they just don't seem to do that. Hey, how'd you end up on my website? Someone clicked on something. What'd you do?
I clicked on something.
Wow, that's cool. There's my website. That's not where we're going. So here we go, an adventure in image processing. I'm going to tell you a little bit about what I've done, and then I'm going to tell you a little bit about SOFIA that I flew on, and then I'm going to tell you a little bit about Canopus, which is what we're trying to do. So I'm going to run through these really fast because I'm assuming a lot of you guys already have this background. But in getting your PowerPoints, I realized that a lot of you might be able to use some of these slides, so I stole them from other people. Kevin, thank you. Tim Buck isn't here yet. I stole some of these from him. I don't know where I got half these slides from, but we all know that, white light, all the colors of the rainbow. Our eye, though, can only detect 3 colors, and that's just really an important concept if you want to get the other frequencies of light across to kids. That's all we can see. And then magically, our brain takes these colors and puts them together. We spent a lot of time on this, talking about the logic of that, red and green making yellow. And our brain mixes it together and gives us the colors that we see. Now, if you look through your color gels right now, so everyone look through their color gels right now, look through all of them real quick, but then look through the red one. Okay, so let's look through all of them real quick. Red shows in red, blue shows in blue, green shows in green. And it's obvious to you, the kids, this is like magical. But now go back to the red one. Everyone put the red one in front of your eye. Ready? Hold on. Are you looking through red? Is everyone, eyes on me. Everyone's looking through red? What happened? Keep looking through red. Look at that. And now look through red.
Blue and green.
Yeah, huge concept here. When red is on black, red looks red, right? My brain's telling me it's red. All of a sudden, when red is on white, I think in my head that the red turned white, right? But no, everything's red. The white is reflecting all colors of light, and so the red is coming through that red filter. So is the red from the red. Red is reflecting red, white is reflecting red. And these like a huge thing for the kids to get across. So if I'm looking at stuff in space, what's the background I'm looking against? Is it a black background, or is it in front of some cloud of dust that's white? That's how I'm going to have to decide what colors are showing through. So filters, and it still does say white shows in all 3 gels on this screen. You just can't see it. I kept the letters down there. And our red filter always works the best, so that's what we focus on. I'm going to go through these pretty quick, too. Now I have some pretty pictures. Again, I think I stole these from Kevin or from some website he gave me. Here's the Helix Nebula, planetary nebula. What am I trying to focus on in this thing? That might determine what kind of colors I use to look at it. So if you look through the green, you kind of see this greenish around the center, which is oxygen. If I look through red, then the outer halo pops out at me. That's nitrogen and hydrogen. But if I look through the blue, that white dwarf in the center really pops out at me. Okay? So we go through pretty pictures. We go through a lot of them because the kids really enjoy doing this. But here's some more, and I'm just going to kind of zoom through them kind of quick. In this one, all of these images were taken in the red and near-infrared, I believe. But the reddest colors were the lowest wavelength. The bluest colors were the higher wavelength. And we talked about that. So now all of a sudden I'm not just using red, green, and blue. I'm using red, green, and blue to say lowest frequency is red, highest frequency is blue. But it's this one's Hubble. So in this one, I wouldn't be able to see some of that. Some of that would be outside of my detector in the back of my eye. Here's another one. There's the explanation. And so all these are on the slideshow, and so you'll be able free to steal them from me, and I stole them from someone else.
But it's an abstract.
Huh?
It can be an abstract.
I'm not sure where the slideshow will be.
In the site, where the program, and then you have abstract, and beside your name will be the material.
Okay.
If you give it to me.
If I give it to him, so I will give it to Alan. Now this is what I like to play with. Look through your red filter. And it's like boldly stole from Kevin McCarran.
I would never, ever write a sheet just that.
I write this on my board at the beginning of class, and the kids come in, they look through their filters until they find the red one, and they're like, oh. It's really funny. So it says, Piper, she's cool. Okay, so this is active astronomy, and this is all SOFIA stuff and extensions of SOFIA stuff that we've been doing up at Yerkes Observatory Viv for, I don't know, like 100 years. And that's part of the reason I got to fly on SOFIA. Then we talk about the spectrum of light. Again, I'm going to fly through these just a little bit, and we talk about why things might be different colors, and why now all of a sudden I know that there's more than just this little tiny bit that my poor little eye can see. If I want to see something else here, I need something that's a filter that's letting things through at a higher frequency than violet. If I'm looking at something down here, I need something that can detect things at a lower frequency than red. And all of a sudden, I don't even have to remember the words ultraviolet and infrared. Infra means below. They all know that from their vocab. Infra, below red, that would be a lower frequency. Ultra, above violet, that would be a higher frequency. What gives you skin cancer? Ultraviolet. Which one has more energy? Ultraviolet. So high energy, low energy. And they don't have to memorize things anymore. They can just think about it and remember. So here's the challenge. How do we see things? Our atmosphere blocks out a heck of a lot of stuff. And so you broke the eye. It happens all the time. And we've got this little window that we can see through. Hey, maybe that's why we evolved that way, 6,000 years ago. So maybe that's why we evolved, to be able to see the visible light. And we've got, that little bit of, which way it's going to go, like ultraviolet here and infrared down there. And so we put satellites up in space, and we fly airplanes above 99% of our atmosphere. Again, flying. Here's NASA's great observatories to address those issues. Radio waves, that's where we're going to talk to aliens. The radio waves, if you look in this one, a lot of radio waves get through the planet, so we can do that from Earth. And then here's just a nice, pretty Spitzer picture. And at this point, the kids are getting the idea that detectors in my eyes, detectors out in space, and they look through these. And now, this one is Spitzer infrared. I called it red because it has the lower frequency. This one's Hubble near infrared. I can't see this one either, but I'm coloring it yellow because it's kind of in between. And this one's Chandra X-ray. I'm coloring it blue because it's higher frequency. Now, all pictures aren't like that, but I point out to them that quite often that's the way these things are colored. Talk about infrared light. We actually have, I had a fireman come in and use an infrared camera. We now have an infrared camera up at the observatory, and I think Kevin has one at his school. So we do some things with infrared cameras. And then we talk about why we would study infrared. We've got a visible image here, a near-infrared image, and a far-infrared image of the same area of the sky. There's the first nebula, and we talk about the things we can see based on which frequency I choose to look at. Not because they're starting to get the whole idea of those other magical frequencies They're not magical. My 4 eyes just can't see them. And then, of course, the beautiful Orion picture. Okay, so NASA's infrared mission. We've got Spitzer, which we've done some work with at my school. We've got WISE, which we've done some work with at my school. Hubble, which of course we get lots of beautiful images we look at. SOFIA, which I've now flown on. And the James Webb, which we're hoping goes into space someday. So here's a little bit about what we've done with these different programs. We did the pediatrics group, the IASC WISE search, where WISE would pinpoint, they would find some asteroids in space, and then Bob Holmes down in Charleston would take images of them, and then I had students who would, we'd find the coordinates of those asteroids, report those back to Patrick, and Patrick would pass it on to the Minor Planet Center. And so that was one of the things there, you know, me in the freezing cold with Bob by his new 30-inch. We use image processing Astronomical, which I think, Patrick, you're going to talk about that later in the week, or no? Astronomical. That program is still ongoing. We use Minor Planet Center for finding out where those asteroids should be, JPL, looking at the orbits, and there's my asteroid hunters down at the bottom there. And kind of like some of you guys are saying, none of these kids have ever been a student of mine. In fact, they tend to be kind of dead-enders. Some of them are better students, some of them are worse students, but they tend to be the kind of kids who get in trouble, and now all of a sudden they're asteroid hunters. They show up whenever. They show up during study hall. I have to send them away sometimes. But they have found many asteroids, and they're the ones who are working on canopus for me now. So again, it's a really great thing to get kids who normally wouldn't be doing wonderful things. I also, there's, we have some for that now. So I also participated in the NITARP program. It's a teacher, it's Spitzer information, it's archival information. You get paired up with another group of a teacher and students and astronomers from somewhere else in the United States, and you work on Spitzer archival data, you do real research, and you present your findings at the IASC. If this is something you're interested in, I have some brochures back in the back there, and it looks like this. They're right on the table there. And it's one of those things that if you want to get involved in it, if you're a teacher, they'll pair you up with someone else, and it's a really cool opportunity. Present your findings at the IASC. This is another program that, we're using the infrared. What our program was we were looking for stars that are buried in the infrared that were not varying in visible light. And we produced light curves to do that. We started out doing that by hand using the aperture photometry tool, and we took the information and plotted it right on an Excel plot. And then when we got to Caltech in the summertime, we used their really powerful IRAP program. But we did it by hand, and we learned a lot doing that about light curves and processing data. So that was our NITARP experience. Let's see, SOFIA, we of course do the color filters that we just did today. We do IR detectors, we use solar cells and squealers or speakers to turn infrared light into energy, turn that energy back into mechanical sound. And then we also do Python programming. Mark Bear-Too, who talked yesterday, was it today? Yesterday. But Mark has come out to my school many times now and helped my kids program, just learning basic programming and then talking to them about SOFIA and how he's doing the programming so that the camera can talk to the computers and so we can get the images that are coming in the telescope. So the SOFIA Experience, again, we have some brochures for the SOFIA program. This year, they chose 6 teachers to fly on SOFIA, and I was one of them. And that was June 1st. They told us, I think they told us like May 5th or 6th that we were flying, and then they told us about a week ahead of time when we were flying. We had like no time to prepare. The first 6 people were really kind of guinea pigs. They called us the golden guinea pigs at first. I probably shouldn't say that, you're recording it. But now we're the SOFIA 6, and what they wanted was for us to go up on SOFIA, see what kind of interactions teachers could make with the scientists on SOFIA, with the different instrument personnel, just what kind of science we could pull out of it And that's what we did. So you can search SOFIA Education Outreach. There's also some links at stars@yerkes.net. And here's a quick slideshow. They paired me up with another teacher. The next application process, you will go in as a group of 2, and those 2 people will have a plan. How are you going to integrate this into your classroom? What are you going to do beforehand? What are you going to do afterwards? What are you going to do during the trip? Whereas with us, it's like get on there and see what you can do. So they paired me up with a middle school teacher, and it worked out really great. We have to go through flight training. You have to have oxygen with you at all times. That's Bob Rubin. I don't know if any of you know him. He was the principal investigator doing science on our flight. And you have to keep oxygen with you at all times because if you lose pressure at 44,000 feet, you've got 9 seconds to get that oxygen on. During that point, when you're that high, the pilot has to wear an oxygen mask because we don't want him passing out. It's a little rule. So these are the little packs we carried around with us, and there's me holding the pack, and my headphones on. It's really noisy up there. But this is all part of our training before we could even fly. They even showed us how to open the door in case of an emergency. They showed us how to open the hatch on top in case we had to scramble out. And I'm thinking if Peggy Piper has to open that door to save your life, it's probably a little too late already. They have flashlights on board, which if you don't return them, results in some pretty stiff penalties there, death by stoning. But it can get really dark up there, obviously. So here's our group, including Bob Rubin, our scientist, off to the side. Security's really high. They tell you your flight path. The interesting thing about the flight path is you're keeping your plane pointed in a certain direction because you're looking at an object in the sky. You're not trying to get from Palmdale to Chicago. You're trying to keep your plane pointed so that you can look at an object. That was pretty cool. Weather was really important. And these are all things, it's like how am I going to integrate this into my classroom? Weather is really important at 44,000 feet, not the weather down here, but the weather up there. We actually flew over some of those terrible storms you guys are having in the Midwest during this flight. We kept flying. Lots of different people.
And are you going to say?
Oh, they had to close it. Yeah, I'm trying to go fast because I don't have a.
I know, it's really
okay.
cool.
It was really cool. So to close the door, they all run to the back. You can see my YouTube. It's actually in there. To close the door, they actually all run to the back of the plane by the telescope. The pilots had seen St. Elmo's fire, and so when you see St. Elmo's fire, there's cloud-to-cloud lightning, and they expect that they're going to be running into some clouds, and so they radioed down to the flight director, and they're like, oh no, we better close the door. So they'll go running back there, and they close up the door, and they got it just in time before we went into some moisture. And then pretty soon it was pretty obviously that we were in some really tall clouds. We had some turbulence, we all had to sit down, but it was like a little emergency, and we didn't know what was going on, and we asked them after the fact, and they had to close the door. But then they opened it back up, and I think I have a picture in here later. They have this little screen that shows you, how far the door is open, how far the door is closed, whether the mirror is centered, all sorts of really cool science on there. So yes, we did go over those storms. We did have some times where we had to close the telescope, but afterwards they checked it and nothing bad happened. So they go through the station time. There was our flight director, really interesting for students that she's a female and she's the person in charge. Nothing happened on that flight without her approval. Doctor talked about fatigue because we fly all night and you do get a little punchy. Hopefully the pilots weren't overtired. And then we got on board. Once we were on board, I got to fly in the cockpit on the way up, and it was amazing. I'm afraid of flying, by the way. Got to sit in the jump seat for takeoff. It's really kind of cool that they still use masks. Even though they have all this other stuff, they still pull a mask to make sure they're in the right spot. And they couldn't find their little sun visors. I found them back behind my jump seat. They still had a flight engineer on this flight, and that's going to change when SOFIA goes into a little rest period this fall to winter. They're going to automate everything, so they'll just need a pilot and a co-pilot. The pilot and co-pilot right now are test pilots, so they're fighter pilots, they're big-time military guys. Once they're done with the test phase, it'll still be military guys, but it won't have to be this guy who has flown like 10 billion different kinds of planes. And he felt really safe in his hands. He felt like he knew what he was doing. And the flight engineer, he was fantastic. He was an older gentleman, and every single thing that happened on those boards, he knew. He pointed out to the guys there were a couple of dials that weren't quite right. He said, I could tell because of this. He was fixing things throughout the flight. So now it's sunset, okay? It's just sunset. And now we're off to our flight. Here is the flight director watching the telescope door open up. And you can see on the top and bottom, the telescope on the bottom picture is, covered halfway. Here's our flight path. The blue plane is where we were supposed to be. The yellow plane is where we were. But once again, the pilot wasn't so concerned with staying on the path as to the pointing. And he was one of those guys that he wanted both. He wanted to be on the path and pointing in our direction. So he kind of took that as a personal challenge. One of the young ladies, master's degree in physics, I think, she was in charge of the telescope itself. Yeah, there's Sophia.
And point this pass around?
Yeah, go ahead. Just be careful.
Well, actually,
Be careful of the wings, because the wings will fall out. So just, make sure the wings are not loose. They can do it, Viv. They'll be okay. Now here's the councils up where the science is happening, and that's what I was most interested in. Bob Rubin was on this flight. He was looking at the Saturn Nebula. I got to talk to him ahead of time. He didn't know what constellation it was in, and so that excited me. And so that night I printed out a star chart, got it with Viv, and I got some pictures of the Saturn Nebula, and I gave them to him that night of the flight. And that was pretty cool that I got to have a little input there. So I'm going to put together a little collage of where it's at, what the Saturn Nebula looks like, take a picture of Saturn, color image with Salsa J, and then get all that to Bob Rubin. Terry Herder is the PI on Forecast, which is the telescope that's on there right now, and his team is still getting Forecast working up to speed, and so he had a whole team there that was making sure the images were coming through and that the camera was working correctly. A young lady from Cornell, that's where Forecast was built, just like we're building Hawk, they built Forecast, and she's logging every single image that was being taken, even though that's all computerized, she's logging it by hand. Here's Bob Rubin when they got some good images of the Saturn Nebula, and that's what's so cool. I mean, I've been in the 24-inch, I've been other places where we're taking images. It was really similar. You don't know if you're going to get good images until you get the good images. And so when he did, I mean, you can see everyone else is smiling and Bob's just going. So, but he was pretty excited. He offered to buy champagne. And here's the pictures of the Saturn Nebula. And so that was neat to be right up there by the councils and see what was happening, and also get a chance. I read Bob's abstract. I had a chance to talk to him and have him explain different aspects of it. And so understanding the science, I think, is an important part of future flights, teachers going on these flights. And there's me sitting there with the Saturn Nebula in the background, pretending I'm doing something. And now it's pretty much sunrise. And there's the other teacher I was up there with, my SOFIA counterpart. And here's me reading on the plane. This is something I'm actually going to use at school because we show the teachers reading every place. I'm reading a novel on SOFIA. Actually, this is on a different plane, but I'm not going to tell them that. But it's one of those things to keep our kids reading. Oh, it's on here now. Okay, and here's us getting off of SOFIA. So it's morning time. We've been on this flight all night long. This came out to cheer me on. She also took videos of my takeoff and landing. I did ask if I could steer, and they said no. And you can look up, I have 2 YouTubes online, and you look in YouTube, Peggy Piper SOFIA Flight, Peggy Piper SOFIA Training, you'll find my 2 YouTubes. And then the SOFIA folks wanted us to do something, and I'm like, okay, I could take notes, and my nephew had one of those little flip video cameras, and I'm like, okay, I'll video journal. So I did a video journal, and it's okay. I wanted to go viral, though, so I was like, yeah, let's go visit it. So what are we doing next? And it's like, how does all this stuff connect? Well, we've done the light curves. We've done asteroid searches. What we're starting right now with my same asteroid guide is we're using MPO Canopus to do light curves of asteroids. And then I'm going to see if I can somehow, make that work with SOFIA. I'm not sure. There's got to be a way. The resources we're using right now are Bob Holmes, Tyler Linder, and Bob Conwell at EIU. Tyler actually we went down and learned from him, and then he came up and helped us understand more about the program. And it's one of those programs you have to commit to. It's solves the J when I've used that with my students. Once they get on there, they're better at it than I am within minutes. Astronomical is a little tough, but the kids, again, caught on much faster than I did. Canopus, they're catching on pretty quick, but it's a real commitment if you want to use it. And
horizontal scale there.
this is time, I think it's Julian days. And I'm going to do a real quick demo of Canopus. So, but yeah, that on there, it's actually 2 different sessions. Bob took this one night and took that another night. And this was some bad data that we took out. Okay, so we're going faster. Okay, so our hopes are to develop and document the techniques that we're using, request our own images using Skynet, and take our own images on our own telescope to do these light curves. And actually, that stuff will be contributing to, there's not a whole lot of light curves out there, and we'll be able to publish this information and possibly publish a paper, and of course save the world. That's always important. So we're going to, and I always just stick this Hubble Images on because I like it. But we're going to take a real quick look at Canopus and show you what it can do, and if you're interested in learning more about it, we can give that a try. So Canopus it's an image processor, but it's got more to it. And there's basically different pages. So this is the measurement page. This is the blinker page. We're going to do that one first because it's always fun. We're going to open up some of a set of images. And just like when you're doing any asteroid search, you need a heck of a lot of images, well, unless it's a really bright asteroid. And so we're going to look at 3 here. I'll go down here. And when I open these up, and I blink them, okay, you can see that asteroid. And that asteroid, well, I guess, no, I don't have time to look at it. Okay, so here it is, here it is, here it is. So it's going between these 3 little stars here, I know this asteroid well, and this star right up here. And so you can actually align these so it's not shifting like that, but I'm not taking the time to do it. Now this blinker is open. I'm going to say pause, but I don't have to close it up. Now I can go to the measurement page. That blinker is still back there if I have to refer back to it. And I'm going to go to photometry. I'm going to start a session. I'm going to start a new session. And I'm going to do the same answer that I did before, 3, 1, 2, 2. And I happen to know the name of this asteroid. This is a bright asteroid, and I should put in the date, I should put in the time. Right now I'm hurrying. So there's 3122, it's named for it. Very nice. Okay, so I calculated its location. I'm going to go ahead and save that. And, okay, hold on. Oh, I need to open one in Magic first. Okay. It's telling me it wants to do one other thing first. I have to go to photometry. I need to go to...
Is this a free download?
This is not a free download. This is a license. Oh, did she leave the room? This is a license. I believe if anyone's interested in it. Canopus, it's not a free...
Well, no, but it's reasonable. It's like $65 or something, and it's, I don't know, I paid a little more and asked for a license for a class, and the developer of it is very interested in helping us.
So the program now knows what area of the sky I'm looking in, and notice there's one little thing there that's not there. That's the asteroid. Well, I guess that could be the asteroid, that could be the asteroid, but that happens to be the asteroid. All these other are reference stars, and so the program knows that those stars should be there. Then we go in and we collect data, and we're going to run out of time here. So let's see.
Go ahead, Peggy.
Keep going? Okay, then I'll make sure I did it right. Okay, so we already calculated that. We're going to edit this one. Okay. And this is the really beautiful part, so let me make sure I get to this part. All I do is I pick the first image I'm interested in. In that image, And there's instructions there. I picked some reference stars, so I'm going to pick that as a reference star, star 1. I'm going to pick that as a reference star, star 2, and then I know that that's my asteroid because I've done this 10 million times. There's my asteroid. Okay, and I could pick more reference stars, but I'm going to move on. Now I pick the last in my series. Now this series is one set, and then he had like a half-hour lapse, and then he started again. And so that's one session. So I'm going to pick this last one. And again, it's going to say what it thinks. Hey, where'd you go? Oh, there, okay. It's saying it thinks star 1 is over there. Well, star 1 is actually right there. So I'm going to reset star 1. It already knows where star 2 is. And my target is all the way over here now. Okay? There's my target. That's my asteroid. I say next. I don't want to save anything. And now I'm going to process all of these in this first set of images. Okay, here we go. I can accept these one by one. So I double click on the first one. I take a look. Yep, that's star 1, that's star 2. There's my target. And I can accept them manually. But once I'm pretty sure it's on track, I can just go to auto and say, yeah, go ahead. And I can watch it go across the screen. Now, the beep is on, the really nice part. I can turn the beep off while it's running. And it's going to process all these images. Now watch right about now, this is one part I do want you to see. Do you see any problems emerging as it moves across the screen? Yeah. And so you can change those things, just like on other programs, you can change the aperture, you can change the background that you're subtracting. You can, just chop that part out. And we do lots of these light curves. We want lots and lots and lots of images. So there's a lot of things you can do, but on this one we chose to just chop out that little section. I'm going to let it keep going. It's going to take too much longer. Yeah. And notice what was in the center, it was actually including both of them. It wasn't centered on the asteroid anymore. It centered itself between the asteroid and the reference star. So it was keeping it in there as long as it possibly could. Oh, it's almost done. Okay, now I want to go back up to that session I started, and some of this is, just words, and the kids really catch on to this right away. I want to edit this session. Okay, so if I look, I can see that, yeah, that bright star caused a problem. I do see that there's some variability here, but that bright star, because it's, went so close to the star, thought the asteroid got really bright. So my scale is all switched down. I really can't see what's happening here. What would happen is I would come back in here and remove those observations from my data. What I'm going to do is kind of just ditch this one right now and go to the light curves, because I've done this one before with the boys. It won't let you leave until you save and say OK. Okay, so I'm going to go to my light curves. I'm going to look at the raw data. 5 is there. I could look at it, but I'm not going to look at it. I'm going to look at 1, which is the same information but cleaned up. And I can see that there's a curve there, right? Now, that's really kind of nice, but wait a minute. What if I want to look at that and the following session that Bob did that exact same night? I can take 1 and 2, sessions 1 and 2 on that same asteroid and put them together. Now, you can see there's a curve. what's going on there? Well, the brightness changed. There was something different with the seeing at that point in time. So what I'm going to do here is I'm going to move it. And I'm just going to see which direction I need to go in. Okay, oh, that was really good. I got them lined up again, and all I'm doing is saying, okay, they were off, they were still, I mean, I'm comparing them to a reference site, so I'm still good, but there was something different there, maybe it was the electronics, maybe, who knows, and so I had to put them back together. One more thing, and then we go one step further, and we look for the period, and we do that like this. And we're trying to see what the period of that asteroid is. The period of the asteroid can tell me if it's got 2 bright points, a bright point on this side, and then one turns bright here, and then dim here, and dim here. Or maybe it has 3 bright points or 4 bright points. It could be whatever. That's what the orders are. That's going to help us understand what its composition is, what its shape is, and if it was going to hit Earth, what are we going to do to nudge it? If it's a pile of rocks, you can't nudge it as easy as if it's a nice solid asteroid. So, okay.
Thank you. I think Peggy is arguably the highest flying HV teacher.
Thank you. No one's been on the shuttle or anything, have they?
Yeah.
Question?
Yeah, you work with your students with this, right?
Yes.
So how old are they, and within which context you work with them?
They're juniors in high school. I teach physics, astronomy, and meteorology. I do this a little bit in all my classes, and then kids hear about it, and my ASC guys are actually kids. 2 had been in my study hall last year, 2 more just came along for the ride. I just recruited 3 young ladies this weekend. I was at a graduation party, and they're interested in doing asteroid work. So none of them, when we went to NITARP, all 3 were my students, but the other kids, they're not necessarily my students. They'll come during study hall, they'll come before and after school. So we kind of do it everywhere.
And in case, imagine a teacher, for instance, our Portuguese teacher that is running the asteroid search campaign would like to enroll in something like this. Would there be an opportunity? Would there be images flowing her way as well to produce the same?
Well, and that's where I started with Patrick and Isaac. And so with the Isaac program, there's people all over the world involved in that. And that was incredibly good training. And so the 3 young ladies I'm going to start with this fall. I'm planning on starting again with the asteroid search while my guys keep going further. My boys have also presented to local groups, to like grade school children, because once they understand it really well, and they can speak in the language of the kids. But yeah, from all over the world, Patrick, how many countries do you have doing Isaac?
So that I know, but I mean, this is a step
okay,
forward.
A step further. That's what, yes, love to, and Viv, hopefully you're going to help me on this. This is kind of uncharted ground, and working with Tyler Linder at Eastern Illinois University, he's a grad student. Actually, he's an undergrad, but he was in the Marines first, so he's an older undergrad student, and he's very passionate about making this work. And so if we can develop this to the point, I mean, we fumbled through this, and so if we can develop this to the point where it's a little bit easier to pass on to others, then we want to request our own images. So I think, learning how through Astrometrica, and now that we know how, requesting our own images and going after asteroids that we think are interesting, I think that's kind of the key. And then everyone, I mean, if you have access to Skynet, you have access to obtaining all those images.
So when you start looking for a partner, make sure you contact us.
I'll let you know. And Bob Holmes is a big part of this. He's the one who Tyler's been working with to get this started. So I'm hoping that they all have a lot of advice for us on what to do next. But yeah, it would be really cool if we could do it with people all over. So.
Okay, well, thank you. Woman needs no introduction
Well, here's what I do at the observatory.
Thank you. Please stand by.